going to see what's formed from potassium when it undergoes alpha and beta decay. Potassium-40 is the stuff in bananas that makes them slightly radioactive. I don't think it actually readily undergoes alpha decay, but let's look at what would happen if it were to shoot out an alpha particle. An alpha particle is basically a helium-2+. It just has 2 protons and 2 neutrons. So alpha decay is a real fission event. The nucleus splits apart and becomes this alpha particle with 2 protons and 2 neutrons, and what's left has 2 protons less and 2 neutrons less. So what determines the identity of an element? It's the number of protons. So now, if this nucleus has 2 less protons, it essentially became the element 2 spaces to the left on the periodic table. So if we started at potassium, well, we have to go up to this period, and we go to chlorine. A way to double check that that's the correct element that's formed is that its atomic number is 2 less. That means it has 2 less protons. We went from 19 to 17 protons. So we would make chlorine, and it would have a total of 4 less nucleons, losing 2 protons and 2 neutrons. So instead of having a mass number of 40, it would have a mass number of 36. Now, let's look at beta decay. So let's take our initial potassium-40 here. What happens in beta decay is that a neutron has an identity crisis, and it splits apart and becomes a proton and an electron. When they first observed this happening, they knew that a particle got shot out at very high speed, close to the speed of light, and that it was negatively charged. And they called it a beta particle, and soon figured out it was an electron. Now let's not forget about that proton that gets made. It doesn't get shot out. It actually stays in the nucleus, and we get an extra proton in the nucleus. That increases the atomic number by 1. So when beta minus decay happens, there's 1 extra proton in the element that's formed, and we move 1 to the right on the periodic table. So when potassium-40 undergoes beta minus decay, it goes from being potassium to calcium. And let's think about its mass number. The potassium-40 lost 1 neutron, but it gained a proton. So overall, the number of nucleons is unchanged. And we make calcium-40. Now let's look at one more thing that can happen to potassium-40 in real life. It can undergo beta plus decay, which is where instead of a neutron having an identity crisis, the proton does. And this proton shoots out a particle that's kind of like an electron, but positive, and it's an antiparticle of an electron called the positron. And also created is a neutron, and that neutron stays in the nucleus. So the nucleus gets an extra neutron here. So what gets formed from our potassium-40? Well, we saw that we lost a proton this time, so we're going to move left on the periodic table, but only 1 spot because the atomic number only dropped by 1, so we're going down to argon. And again, the number of nucleons doesn't change. We just have a shift between proton and neutron again. So the mass number is still